Thank you for joining this lesson. Please make sure once you join, you invite your friends, invite your classmates. Yeah, kindly click the share button, then invite a friend, invite someone. Yeah, you can just hold on as I share to a few individuals. Just hold on. Continue joining, continue joining. We're going to start with paper 1 mathematics. Yes, good morning, boys and girls. Welcome for this lesson. As I promised, we're going to begin with mathematics paper 1. Just before I go to any question, it's very good I clarify that what we call mathematics paper 1 is strictly form 1 and form 2 work. So when we talk of paper 1 mathematics, whose code is 121 stroke 1. This means strictly form 1 and form 2 work plus any form 3 work and form 4 work, whereby the basic of that work or that topic is found in form 1 or form 2. Therefore, we have form 3 and form 4 topics, which are an extension of form 1 and form 2 work. Those topics in form 3 and form 4 can also be found in paper 1. I've said and I'll repeat that form 1 and form 2 work make what we call paper 1 mathematics, called 121 stroke 1. But now there are those topics in form 3 and form 4 whose origin is found in form 1 or in form 2. Such topics can also be found in paper 1. We have, for example, trigonometry. We have a trigonometry. That means trigonometry. We have trigonometry 1 in form 2 and trigonometry 2 and 3 in form 3 and 4. Even though they are in form 3 and 4, the origin of trigonometry is book 2, mathematics. That means we can have the same topics appearing in paper 1. We also have the statistics, we have the commercial arithmetic, we have the vectors, and several other topics which are found in form 3 and 4, but their origin is in book 1 or book 2. So that means now paper 2, whose code is 121 stroke 2. This is mathematics paper 2. This paper is strictly form 3 and 4. More so, the topics which are purely originating in form 3 and 4. Topics which are ideally not taught in the lower forms. Things like probability. There is no idea of probability in book 1 and book 2. That means probability is strictly a paper 2 topic and such things. Therefore, it's good we differentiate. It's good we differentiate the two papers. For now, allow me go to the discussion of this paper. I'm going to take you through the Pangani Pre-Mock. This is the 2023 examination. As we discuss this exam, I want you to know that we are still going to consider what we've just outlined, that being a paper 1, is it having form 2 and form 1 work as the major composition? Then after that, we check whether there are a few topics which are from the upper forms and are found in the same paper 1. Therefore, we're going to begin. We have the number 1 question here. This question says that all odd numbers from 1 to 10 are arranged in descending order to form a number. Write the number. So there is a number formed when the numbers between 1 and 10, which are odd, are arranged in a descending order. Remember, an exam is a set of instructions. The examiner wants to know whether you can follow the instructions given up here. The first thing is odd numbers. So we want to know whether you really know what odd numbers is. The next, we want to know whether you are aware of descending order. So those are the main words in this particular exam. Therefore, let us now follow the instructions. We're going to list the odd numbers between 1 and 10. 1 is included. 2 is not an odd number. Remember, odd numbers are the numbers which can be divided by 2 without a remainder. Therefore, 1 is one of the numbers. They cannot be divided by 2 without a remainder. These are the opposite of even numbers. Therefore, 1, we go to 3, we go to 5, we go to 7, and finally, we have 9. Therefore, these are the numbers we're going to list. But remember, the numbers are not going to be listed just as we have stated them. They are supposed to follow what we're calling a descending order, which means, again, a student has to know what a descending order is. And a descending order is from the largest to the least. Therefore, we'll begin with 9, then 7, then we go to 5, then 3, and 1. So this is the number formed when all the odd numbers between 1 and 10 are listed and they are arranged in what we're calling a descending order. Therefore, the number is 97,531. So this is the number formed. You get a mark for that. The next, we are told to write the total value of the second digit in the number formed in part A, Roman 1 above. Therefore, this number formed now, we want to write the total value. Again, the examiner is examining whether students know what total value is and whether we also know which is the second digit in a given number. Therefore, we have this number here, the first digit, the second digit. So the second digit is 7. Now, the other thing we're going to consider, now that you've known the number itself is 7, the other thing we're going to consider is the place value of this number. So when we multiply a digit and its place value, we get the total value. Therefore, the place value, the number itself is 7, and the place value is, we have from the right hand side, this is ones, tens, hundreds, thousands. So 7 is at the thousands position, or rather place value. Therefore, we multiply 7 with 1,000, and this will give us 7,000. This is what we call the total value, when the digit is multiplied by the place value it occupies. So that gives us 7,000. The next is express the value of the number in part A Roman 2. Part A Roman 2 as a product of its prime factors in power form. Again, we are still in the same topic. Remember, this is a natural numbers factorization now. Therefore, we are having 7,000 now. It is 7,000 which we have been told to express as a product of the prime factors in power form. In power form. Therefore, it has to be understood very well that we will begin now expressing 7,000 in prime factors. Therefore, by 2, because 2 is the least prime factor, we're going to have, when 7,000 is divided by 2, we're going to have 3,500. Yeah, 3,500. Then we continue dividing by 2. We can divide now 3,500 again by 2. This will give us 1,750. 1,750. I can see it's still divisible by 2. We continue dividing by 2. So we're going to continue from let me get a good space. Remember, we have 7,000. We are beginning with 7,000 by 2. This gives us 3,500. Then by 2, we have 1,750. We also now have to divide this one by 2. So 1,750 divided by 2. This gives us 875. 875. From there, we can confirm whether 3 can divide. No, but we know very well that 5 can. So by 5, we have 875 divided by 5. This gives us 175. We move again to 5 again. By 5, this gives us 35. Again, by 5, this is going to give us a 7. So 7 is the least prime factor. Therefore, we're going to have now the prime factors as shown here. So we got 2, 2, and 2. So 2 is appearing 3 times. So we're going to have 2 times 3, 2 to the power of 3, sorry. Then multiplied by, we have 5, 5, 5, again 3 times. So 5 raised to power 3. Then finally 7, which is just raised to 1. So 7 will just remain as it is. So 7,000 expressed as a product of its prime factors will be 2 power 3 multiplied by 5 power 3 multiplied by 7. So this is the number in its prime factors form. Therefore, number 1 is done. That was a Form 1 question. So Form 1's in the room, you can also grasp something. Let me get to something else. In the same paper, the number 2 question. It's good we read the question together. We are told that a shopkeeper bought a bag of sugar. He intends to repack the sugar in 40 grams, 250 grams, and 750 grams. Determine the least mass in grams of sugar that was in the bag. That was in the bag. Therefore, what we're going to do is to first of all understand what this shopkeeper is attempting to do. We are told that a shopkeeper is buying a bag of sugar. Then he wants now to repack from the bag of sugar to portions of 40, 250, 750. These are grams. Then we are told to determine the least. So the word to be underlined is the the least. We have to underline the word the least mass. When you hear the least, what should come to your mind is what we call LCM. Sorry for the disconnection. We're going to obtain the LCM, the least common multiple of the proportions given here. Therefore, the LCM of 40, 250, 750 is going to be obtained. Remember, in a similar question, you can be asked to determine the greatest mass. The greatest mass. In such a case, remember to talk about what we call the GCD, or the highest common factor, the greatest common multiple, GCD. Therefore, we're going to have LCM of 40 just due to the word least, the least common multiple. LCM of 40, 250, and 750 grams. So we're going to obtain the LCM in this case. So we're going to begin. The least is 2. This becomes 20. This becomes 120. Then 750, very fast, divided by 2. This becomes 375. Again, we can go by 2. This becomes 10. This cannot be divided by 2, so they remain just the way they are. The next is going to be, by 2 again. This becomes 5. This remains just as it is. Then now we can go to 3. When we divide 5 by 3, 5 remains the way it is. 125 by 3, this will also remain the way it is. Let me confirm. 125 by 3. Yeah, it's not divisible. Then 375 by 3. This one is divisible to 125. Yes, so the next is going to be by 5, because we cannot divide by 3 anymore. So by 5, we'll have 1. 125 by 5, this gives us 25. 25. Then we go to 5, whereby we get 1. We get 5 and 5. Finally, we shall have by 5, so that we have 1, 1, and 1 in each case. Therefore, the LCM is the product of these factors here. So we will have 2 times 3. 2 to the power of 3 times 3 to the power of 1 multiplied by 5 raised to the power of 3. Yeah, because 5 is appearing 3 times. So 5 to the power of 3, 3 to the power of 1, and 2 cubed. Therefore, we can get now the exact value of LCM. Remember, this is already the LCM in prime factors. So 2 power 3. Remember, this gives us 8 times 3 times 5 raised to the power of 3 gives us 125. So when we multiply now all this, we're going to have 8 by 125 by 3. This gives us exactly 3,000. So we're going to have 3,000 grams. 3,000 grams. This is the least mass we expect to be in the bag. The least mass we expect to be in the bag. So when the word least appears, kindly remember what we call the LCM. In case of the word greatest, please remember what we're told that given that the logarithm to base 10 of 2 equals to 0.3010, and the logarithm to base 10 of 3 equals to 0.4771, without using tables or calculators, find the logarithm of 0.036. Of course, to base 10, correct to 4 significant figures. So when given such a question, what you're supposed to ensure is that you have expressed the given number here, 0.036, in terms of 2 and 3, because those are the provided logarithms. So what we're going to do in such a case is that we're going to have 0.036 expressed as 36 out of 1,000 as a fraction. First of all, 36 out of 1,000, it will give us whatever we are having here. Therefore, 36 out of 1,000. Now we will begin expressing 36 in terms of 2 and 3. So we express it as prime factors, and we ensure that the prime factors in the expression are going to be 2 and 3. This is a form 2 question, remember. Therefore, 36, when expressed, let me begin by 2. I'm going to have 18. By 2, I'm going to have 9. By 3, I'm going to have 3. Yeah, so 9 equals to 3 by 3. Therefore, we're going to have 2 squared multiplied by 3 squared. Therefore, 36 equals to 2 squared multiplied by 3 also squared. When we get now to logarithms, we are supposed to know that now we are operating the logarithm of 2 squared multiplied by the logarithm 2 squared multiplied by divided by 1,000 divided by 1,000. Therefore, what we shall have here is going to have the log. Because we talk of the laws of logarithms, when we have a multiplication, it should be known that we add such logarithms. Therefore, in this case, we're going to have, instead of this power here, we're going to have what we call 2, the logarithm of 2. And instead of multiplication, we have an addition. Then here, instead of 3 raised to 2, we're going to have 2, the logarithm of 3. 2, the logarithm of 3. Then to base 10, the logarithm of 1,000 is usually equivalent to 3. Therefore, we're going to have now 2. It has already been provided as a 0.301. Then we add 2, the logarithm, which is 0.4771. That's the logarithm of 3. Then we divide everything now by 3. From this now, you are beyond the level where the examiner had restricted you from using the tables and the calculators. So now we can compute now 2 into 0.301. Then we add to 0.4771. This will give us 1.5562. Then now when we come to logarithms, it has to be known that noted that dividing means subtraction. Therefore, we're going to subtract 3. Therefore, this one times this plus 2 times this one. Then now dividing by 3 means we subtract 3. Remember, these are logarithms. So the law of division means we subtract the logarithms. So the time we have had This log multiplied by this one, we have added. But now dividing by this means we subtract. Therefore, we subtract 3. So we're going to have 1.5562. Then we subtract 3.00. Remember again, 3 is a characteristic, while the first logarithm here is having characteristics and what we call Mandisa. Therefore, we're going to subtract now. This will be 2, 6, 5, 5. So never subtract such a case using a calculator because you get a totally different answer. But when you arrange your work like this, such that you know very well the characteristic here is 1 and on the other side it's 3, you will arrange it in that order. But when you key in as it is in the calculator, you're going to get something very different. Therefore, now we have 2, 6. This becomes bar 2. So the answer is going to be bar 2.5562. Give me a minute, then we continue. You are not going to get the same answer we have obtained here. When we take 1.5562 and we subtract 3, I'm getting a negative 1.4438. Now, that answer will contradict whatever we are having here. But when you arrange the logarithms very well, such that this is the characteristic in the first logarithm point, 5562, then the other one is a characteristic which has no Mandisa. You begin with it here as a 3.00 elsewhere. Then you begin now your subtractions. Remember, I've said an exam is a set of instructions. They are not just questions, a set of instructions. Now, I want us to check whether we have answered satisfactorily. Number 3, we had been told that correct to 4 significant figures. 4 significant figures. Therefore, we have to time our answer until it's 4 significant figures. And this is going to be bar 2, which is the first significant figure, then 0.556. Therefore, this is now to 4 significant figures. 4 significant figures. So what we are having here again, number 4. Number 4, we have a fraction, half of 3 out of 2, then plus 1.5 into brackets, we have 2.5 minus 2/3. We close the brackets, then divided by 3/4 of 2 out of half, 2.5, sorry, divided by half. Therefore, we should know that in such cases, we apply what we call BODMAS. BODMAS. So in BODMAS, we operate brackets first. So in the numerator, we're going to first of all subtract 2.5 with 2/3. Then after that, there is what we call off. This one means multiplication. Wherever there is off, you multiply. Therefore, we're going to multiply this part again as the second operation. Then after that, we have divide. No, there is no division in the numerator. We go to multiplication. Yeah, there will be a multiplication of whatever will be in the brackets here now after subtraction with 1.5. Then we have addition. Whatever we will get after carrying out the multiplication, we add to the answer on the other side, and we will be done with the numerator. Then the denominator, you do the same. We begin with off because there is no brackets in the denominator. We begin with off, then the division, then the multiplication. Then now we compute the final answer, whereby we will have to combine the numerator and the denominator. Kindly copy the question just as it is. You can even screenshot it, after which you are supposed to work it out. You can present your answer later through my phone number, which is 0704 153 3 66. Therefore, you can present your answers yes, so that I may check whether you attempted and you had the right answer. The next question is a graphical, but we are again in Form 1 work. Using the grid provided below, solve the simultaneous equation. Solve the simultaneous equation using the grid provided. Therefore, we're going to have a grid here. There is a grid here, whereby we'll use it now to solve these simultaneous equations. We have an equation here and another one here. Then we're going to use the grid provided here. Here is the grid. A grid is a graphical page to solve the simultaneous equations. It should be noted that simultaneous equations can be solved in very many ways, including substitution, elimination, and now we are having the graphical method. We also have in book 3 what we call the matrix method of solving simultaneous equations. Therefore, in this case, we've been commanded now to follow the graphical method, and it is what we're going to employ in this question. Therefore, the simultaneous equations are as given. The first thing to do to these simultaneous equations is to find a table of values, whereby we need x and y. Then we obtain values now. So we're going to have some values of x and some other values of y, so that you may plot them and we see what we come up with. So 3x minus 4y equals to 10. That is the first equation. The first equation. Therefore, we can begin with, in the first equation, x being 0. So when x is 0, what will be the value of y? Therefore, we're going to substitute our equation now and have 3 x is 0 minus 4y equals to 10. So that we'll have negative 4y equals to 10, and the value of y is going to be 2.5. Therefore, the value of y is going to be 2.5. The next value, we can have the value of x being something like, we can have, that was 0, we can have negative 2. X being negative 2. Let us see what y will be. When x is negative 2, we'll have 3 into negative 2, because that will be the value of x, minus 4y equals to 10. Therefore, we're going to have now negative 6 minus 4y equals to 10. So that negative 4y equals to 16. Negative 4y equals to 16. This means the value of y will be negative 4 when we divide through by negative 4. So y equals to negative 4. So we shall have a negative 4 at this point. We can also try the value of y when x is something else like a negative 1. We can check negative 1. So when x is negative 1, what shall be the value of y? So we have again the equation which is 3 into negative 1 minus 4y equals to 10. And this will give us negative 3 minus 4y equals to 10. So negative 4y equals to 13 when the negative 3 crosses to the other side. So we're going to have the value of y being equal to negative. Now we can divide 13 by 4, giving us 3.25. Therefore, at least we have now 3 coordinates along the first line. We can plot the line 0 against 2.5, 0 against 2.5. So 2.5 is just between 3 and 2. That is the first point. The next coordinate is going to be -2, -4. -2, -4. This is the coordinate. Therefore, we can use those two coordinates to come up with the line. So this is the first line. That is the first line. We can also check the second line. The second line is 5x plus. Yeah, sorry for some interruption. We're going to have now the second equation. The second equation, which is 5x plus 7y equals to 3. We get two coordinates and we work it out. Therefore, we're going to begin with, because we have 5x plus 7y equals to 3, sorry. We're going to draw again a table of values. A table of values. Remember, two coordinates are usually enough, but we get to the third coordinate just for assurance, x and y. So we can begin with the value of x. The value of x being 1. So that now when we substitute 1, we're going to have 5 into 1 plus 7y equals to 3. So that this becomes 5. So 7y equals 2. We take 3 and we subtract 5. And that will give us -2. Then the value of y is going to be, when we take -2 out of 7, -2 out of 7, this gives us -0.28, which is -0.3. We can also go to the value of x being 2. X being 2. When x is 2, we can get the value of y in this equation. So that we have, let me use a space here, so that we have 5. Where we have x, we put 2. 7y equals to 3. Then we'll have 10 plus 7y equals to 3. So that 7y equals to, this is a 3 and this is a 10. So 3 minus 10 gives us -7. So that the value of y now becomes -1. Therefore, when x is 2, the value of y is -1. The value of y is -1. The value of y is -1. We can now move from 2 to a value like 3. Yeah, let's check 3. So when x equals to 3, what will be the value of y? So we'll have 5 into 3 plus 7y equals to 3. So that 15 plus 7y equals to 3. Now we can have 7y being equal to, when we take 15 to the other side, we will have a -12. Yes, so y becomes, when we take -12 out of 7, this gives us 1.7. Negative, that is 1.7. So -1.7. Yeah, -1.7. Therefore, now we can plot these coordinates. We will have 1 and 0.3 negative. So 1 and 0.3 to be somewhere here. Then the other coordinate is going to be 2 and -1. 2, -1, some point here. Then with 3, we're going to have -1.7. So with 3, negative 1.7 is the point at this point. Therefore, now we can just prolong our line. We can produce our line, and you will wonderfully discover that the line being produced now is intersecting the first line at some point. Now, the point of intersection of the two lines gives us the simultaneous solution of the two equations which have been plotted. Therefore, the two equations are intersecting at negative 0.5, negative 0.5, and the y-coordinate is going to be positive 0.7. And of course, from this graph, we can only read up to 1 decimal place. Therefore, because the intersection point or intersection coordinate is negative 0.5, 0.7, that means the x value is going to be negative 0.5 and the value of y is going to be 0.7 from the coordinate of intersection. So that is the point where the two lines are intersecting, So that is how it should be done. We can go to the next. Question. The next question, we are told that when a shopkeeper sells an article, this one is on now commercial arithmetic 1. When a shopkeeper sells an article at 24.05, he makes a profit of 30% on the cost price. We are again told that during a sale, he reduced the price of each article to 22.95 to 22.95. Calculate the percentage profit on the article sold at the sale price. Therefore, what you're going to know is that 24.05 leads to 30% profit. So we can get the cost price of this article, whereby we will say now 130% is 24.05 because there includes the 30% profit and the cost price. What about the cost price of this article, which will be 24.05 times 100 out of 130. So we're going to have 24.05 times 100 divided by 130. This is going to be 18.50. Therefore, this is the cost at which the item was acquired, 18.50. Then now at a certain point, the shopkeeper sold the article at 22.95. She still made a profit. He still made a profit, but now we want to know what is the new percentage profit. So we'll say 100% equals to 18.5 shillings. What about now when the item is sold at 22.95? Therefore, we multiply 22.95 by 100 and we divide by 18.5, and this will give us Kenya shillings. When we multiply 100 by 22.95, then we divide by this figure, we're going to have the percentage as 124.05%, which means now the profit is going to be 24.05%. 24.05%. We have a question from regular polygons and interior angles. We call them plane figures and angles. The size of one interior angle of an irregular polygon is 80. Each of the remaining interior angles is 128. Find the number of sides of the polygon. Find the number of sides of the polygon. So what we're supposed to know is that we can add up all the angles literally and get the same as what we will get after using the formula, whereby we say the sum is given by 180 into n minus 2. 180 into n minus 2. So this formula of 180 equals to n minus 180 times n minus 2 gives us the sum of interior angles. The same value, 180 into n minus 2, can also be obtained by taking the literal addition of each angle there. One is 80, then the others are 128 each, and they are n minus 1. Because we don't know the value of n. We don't know the value of n. Therefore, they are n minus 1. We only know that 1 is 80. So the others, which are n minus 1, will be multiplied by 128. Therefore, the two sides will give us the same thing. Therefore, we can carry out the multiplication. 180n minus 360 equals to 80 plus 128n minus 128. From this point now, we can group like terms together. 180, we subtract 128. This gives us 52n equals to, now we take 80, we subtract 128, and we add 360. This gives us 312. So that now the value of n will be equivalent to exactly 6. Therefore, the number of sides is going to be 6. It is good for people to understand the technique I've applied in such a solution. The size of one interior angle of an irregular polygon equals to 80 degrees. So one of the angles, remember the angles are n, just like the number of sides. So one being 80 and the others being equal to 128. Now we will say the summation of all these angles will be 80 and the others, which are unknown, but we know the size is 128 and they are n minus 1. Now that the total was n and we know 1. Then now that should give us the same as if we use the formula of computing the sum of interior angles in a regular polygon. So that is how it should be handled. That's how it should be handled. The next, we're going to have a simplify. This is 81 raised to 3/4, then minus, this is a fifth raised to -1, then minus 27, then minus 27. Therefore, you can see these are indices. These are indices. What you should know is that when you see a fraction, you know that we are applying the fractional law of indices. When you see a negative power, you know that we are applying the negative law of indices and such. Therefore, it should be noted that at this point, we are supposed to apply the indices, the fractional law of indices, which says in case we have any number raised to a fraction, let's say m over n, this should be operated by taking the nth root of a, then we raise to power m. Nth root of a, and we raise to power m. Therefore, at this point, we need the fourth root of 81. Then now after obtaining the fourth root of 81, now we raise to power 3. That is how we apply such a law, the fractional law of indices. A raised to m out of n means any the root of a raised to power m. So at this point, we will have, whereby we have 81 raised to 3 quarters, the fourth root of 81, then we cube. The fourth root of 81 is 3. Then we cube 3. That will give us a 27. That will give us a 27. Therefore, the solution for this part is a 27. The next is going to be, we have 1 out of 5 raised to negative 1. Again, we have what we call the negative law of indices. In case we have a number a raised to a negative index, we should take the reciprocal of a, then the power becomes positive. And that means now, with a fifth raised to negative 1, we should take the reciprocal, which makes it a 5, then raised to 1. So now it becomes 5. Therefore, rewriting this expression, it means we will have 27 now minus 5 minus 27. And the answer is going to be negative 5, because 27 minus 27 gives us a 0. Negative 5 is now the answer. So the laws of indices are supposed to be known. This is called the fractional law of indices. This is the negative law of indices. We have the multiplication, the division law, and they are all supposed to be understood by students. It's a Form 2 concepts. So this is Form 2 work. Remember, this was a Form 1 concept. That's a Form 1 concept. We have a question here now from inequalities. Inequalities. Linear inequalities. Given the inequalities x minus 6 less than or equal to negative 3x plus 2 less than negative 2x plus 9. Solve the inequalities. The first thing is to solve the inequalities. For us to solve the inequalities, we need to come up with the simple inequalities, which will be simultaneous. And the first inequalities will be running from x up to the term just before the second symbol of inequality. Therefore, the first inequality will be x minus 6 less than or equal to negative 3x plus 2. Then now, the second inequality will start from just after the first inequality symbol, which is here. So we will have negative 3x plus 2 less than negative 2x plus 9. Therefore, we have the first inequality and the second inequality, and we're going to simplify them. Now they are compound statements, we make them simple statements. We will have negative 3 to this side, making it a 4. So we'll have 4x less than or equal to negative 6 to the other side. It will become a positive, and that will be 8. Therefore, in the first inequality, x will be less than or equal to 2 when we divide through by 4. The next, we're going to have, this is negative 3x, and we have negative 2x at this point. So we can take this negative 2, to this side, so that we'll have negative 3 plus 2, making it a negative 1. So negative x less than, this is a 2, taken to the other side, it will be 9 minus 2, making it a 7. Then now we have a negative at this point. When we divide by a negative, we are supposed to get a reversal of the symbol here. Therefore, x, when we divide by negative 1, now the symbol has to change. Then we get negative 7. This one can also be rewritten. This can also be rewritten as negative 7 less than x. So x greater than negative 7 means negative 7 is less than x. Whenever we divide by a negative number, the symbol reverses. That one should be noted. Negative x less than 7. To make this one x, we need to change or reverse the sign to negative 7. That means now we can combine the two symbols. The two simple expressions now can be combined, and they will give us from negative 7 x up to negative 2. So x is ranging from negative 7 to positive 2. This is the simple expression for the solution. The simple expression for the solution. Then we are also having a represent on a number line. Represent on a number line. Represent on a number line. So this solution should be represented on a number line from negative 7 to 2. So I'm going to draw a number line. A number line at this point. A number line at this point. This is 0, 1, 2, 3, then negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8. So from negative 7, which is here, and remember negative 7 is not included, all the way to positive 2. All the way to positive 2, and positive 2 is included. Therefore, we shade at positive 2 because it is included. But from negative 7, which is not included, we just draw a circle at that point. So that is the number line representing. The number line representing. The number line representation. We have another question here from Form 3. We are told it's a vector question. We are told that vectors OA equals to 4i plus 3j. Vector OB equals to negative 2i minus j. And vector OC equals to negative 5 minus 3j. Show that the points A, B, and C are collinear. They are collinear. Continue following. We can use the space above here to show that points A, B, and C are collinear. So what we should do is that we change the vectors, these vectors which are in unit form, into column vectors, and we calculate any vector between the points A, B, and C. Any two vectors. Then we show that the two vectors are parallel. This is what we should be doing in case of such a question. We can show, for example, a vector AB. Vector AB. So for us to get vector AB, we will need B minus A. This means now B minus A, we should have vector OB expressed as a column vector, negative 2, negative 1. Instead of negative 2i, negative j, we will need negative 2, negative 1. Then we subtract OA, which is going to be 4, 3. This is going to give us negative 6, negative 4. Negative 2 minus 4, negative 6, negative 1 minus 3, negative 4. So this is the vector AB. We can also check another vector like BC, vector BC. We need C minus B for us to get that vector. For us to get vector BC, we need C minus B. So vector C is negative 5, negative 3. negative 5, negative 3, minus vector b, which is going to be negative 2, negative 1, negative 2, negative 1, and we subtract now. So we're going to have negative 5, negative negative 2. That means a plus. So negative 5 plus 2, making it negative 3. We have negative 3 minus negative 1, making it a plus. So we'll have negative 3 plus 1. Negative 3 plus 1 makes it a negative 2. Makes it a negative 2. Now we are having vector BC. We are also having vector AB. We can see whether vector, the two vectors can be expressed in terms of one another as a prime, as a scalar multiple of the other. So we can say vector AB equals to a certain constant times BC. And we check whether there is really a scalar multiple for the two vectors. AB is negative 6, negative 4, as we calculated it. The other one, K times BC, which is negative 3, negative 2. It means we will have negative 3K equals to negative 6 using the X component. Negative 3K equals to negative 6, and K will be 2. K equals to 2. Again, we will have negative 2K equals to negative 4, and this proves that K equals to 2. So this is to show that because we have used the X component and the Y component to prove that K equals to 2, then it means vector AB, which is equal to KBC, the value of K is 2, BC. This can also be re-expressed as BC being equal to half AB, and this is to mean that you can say therefore vector BC is parallel to vector AB, just because that one vector is a scale multiple of the other. Then we conclude that the two vectors are parallel. So the two vectors are parallel. And now for the two vectors, we have a common point. So and B is a common point. B is a common point. In some cases, the examiners will give you, the vector you will express. But in an open question like this one, it's optional. We can express vector BC and AB as we have done. We can express vector AC, vector AC, vector BA, vector AB. The vectors are several. So as long as you have expressed them and you follow the working as we have done it, you are going to get your marks. Therefore, you say BC is parallel to AB and B is a common point. Hence, the 3 points now. Hence, A, B, and C are what we are calling now collinear points. They are collinear points. So that is how it should be done. That's how it should be done. We can check number, we can check a number 13 here, which is now a question from Form 4. This is trigonometry 3. It should be noted that I said and I will say again, for the topics which are in Form 4 or Form 3, but they have their origin in Form 1 or Form 2, they can appear in Paper 1. So even though we are dealing with a Paper 1, we can see a topic from Form 4, trigonometry 3. Therefore, we are taught to find the period, to find the amplitude and the phase angle of the function 2y equals to 3, the sine of half x minus 60. Therefore, what we're going to know is that in such a function, or rather we can have the general one, whereby we say this can be y equals to the sine of, let's say, kx plus a certain angle, or the function can be, it can be a function of sine, whereby we have, or cosine, whereby we have cosine of kx plus theta, kx plus theta, but there is always a certain multiplier here, we can call it a. So y equals to a the sine of kx plus theta, y equals to a the cosine of kx plus theta. In such a general function, we usually say that the value of a gives us the amplitude, the value of theta, actually the absolute value of theta, gives us what we call the phase angle, the phase angle. Then when we take 360 and we divide by the value of k, we are supposed to get what we call the period. 360 over k gives us the period. The absolute value of theta gives us the phase angle, and the value of a gives us the amplitude. Therefore, in this case, we're going to have, remember the function is not general, is not y equals to. So the first thing will be dividing by these two, and this will give us y equals to. When we divide through by 2, we get 1.5. 1.5, then the sine of half x minus 60. Yes. So now with the equation now, or the function simplified, we can say the amplitude, or we begin with period, is usually given by 360 divided by the value of k. So 360 divided by half means times 2, which will give us 720 degrees. So the period is 720. The period is 720. The next will be amplitude. Amplitude is given by the coefficient of the sine or the cosine, and we are having 1.5. 1.5. Then the other one is the phase angle. The phase angle. So the phase angle is going to be, even though we have a negative 60, the phase angle is the absolute value, which is just 60 degrees. Exactly 60 degrees. So now we can go to the next, which is number 14. Simplify. We have 20 minus 11x minus 3x squared divided by 16x minus 16x minus 12, 16x minus 12x squared. Therefore, this is a quadratic. We call them quadratic. Equations. Quadratic equations. Therefore, quadratic expressions, sorry. Therefore, we're going to have the numerator and also the denominator.